Okay, good evening, Budhe. We can start today's session. Today we are going to start a fluid part. You will be given this theory note, but unfortunately, I couldn't send that one to you prior to the lesson. Anyway, I will give you the note of today's lesson. Then hereafter we can. Uh, Actually, you will have a note, but then no need of writing the note. Correct. Anyway, today we are going to give the note. Anyway, fluid. Today, so this is the last lesson of mechanics. Uh, in fluid part, actually, we can divide this fluid part into two major categories. One is fluid static. Other one is fluid dynamic. As we did in static and dynamic, actually, we have discussed some lessons in static and dynamic in my previous units. So, static lessons are based on some stationary objects. Dynamic lessons are based on moving object. Therefore, fluid static means studying about stationary fluid. Fluid dynamics means those are the characteristic, or those are the science behind motion, moving fluids, moving fluids. All right. So before that, we had to learn about what is a fluid. So tell me, what is a fluid? I think you have done that thing in your oral uh, oral times today. So what is a fluid? මොකද fluid එකක් කියලා කියන්නේ? What is a fluid? fluid එකක් කියනවා නේද? හ්ම්. බලු මඩවල දායි බලු මඩවල. බලු මඩ. I need your active participation. So what is a fluid? Huh? Rasulu? What is a fluid? Razil? Shashindra? Gandhi? What is a fluid? මොකක්ද fluid එකක් කියන්නේ? No. No. Fluid is not just a liquid. What is a fluid? Fluid. Yes, Rasit. That is very good definition. Yes. If any material, or sorry, if a actually fluid means that is some kind of state of matter, and the particle of that matter can move. That means it is a flowable material. So if it is a flowable material, then we call it as a fluid. Therefore, basically, there are two types of flowable material. One is liquid, other one is gas. Therefore, both gas and liquids are considered as fluid. Therefore, fluid is not just a liquid. Both liquid and gases are considered as liquid, as fluid. Yes, flowable material. Okay. They write that down. They fluid. Topic is fluid. Topic දාගන්න පුතේ. They write this one. A fluid is a flowable material. A fluid is a flowable material. A fluid is a flowable. කවන්න පුතේ කවන්න. It's okay. ඔයාලා මේක ඔයාලගේ මේ fluids කියන lesson එක ඔයාලගේ මොකක් හරි අර static හරි dynamic හරි පොත් වලින් ඉත ඉතුරු වෙලා තියෙනවා නම් ඒක මොකක් හරි page එක පොඩ්ඩක් අතහැරලා වෙනම separate ලියන්න. ප්‍රශ්නයක් නෑ. මොකද අපේ ඉවරයිනේ. හරි. අර මම අර කලින් වෙනම separate books තියාගන්න කිව්වේ. දැන් අර දිගටින් දිගට continue වෙනවා නම් පුතේ පොතේම ලියන්න එපා. දැන් අර lessons ඔක්කොම ඉවර නිසා fluids විතරනේ තියෙන්නේ. ඒ නිසා මේ ස්ටැටික් පොතේ ලියගත්තා නම් වඩා හොඳයි. මොකද ඩයිනමික් පොතේ ඊට පස්සේ එනවා අස රොටේෂන් එකක් වෙනවා. ස්ටැටික් පොතේ ලියගන්න පුළුවන් නම් වඩා හොඳයි. නැත්නම් වෙනම පොතක වෙනම මොකක්ද ලියගන්න. Okay, topic is fluid. Topic is fluid. A fluid is a flowable material. A fluid is a flowable material. A fluid is a flowable material. Therefore, liquid and gases are categorized under fluid. Therefore, liquid and gases are categorized under fluid. This lesson can be divided into two major parts. This lesson can be divided into two major parts. Write this one. Write this chart. Okay. After writing this one, write a main topic. Fluid is static. It is a main topic. Actually, as we defined earlier, all the gases and liquids can be considered as fluid. But in this lesson, we are going to study about liquids only. We are going to study about liquid only. And therefore, we call this part as hydrostatic and hydrodynamic. Hydro means it is a study about liquids. Therefore, in this lesson, we are going to study about liquid part only. Therefore, normally we call this part as hydrostatic and hydrodynamic. And hydrostatic electric. Hydro because it is about liquids. Hydro means liquid. Therefore, in this lesson, we are going to study about liquid only. Actually, we will study about gases in heat lesson. Deenet, what do you want to repeat with it? කොතනද මොකක්ද කොයි හැටිද විශ්වනේ? Before the chart, may I define the fluid with it? The fluid is a flowable material. The fluid is a flowable material. Full stop. The fluid is a flowable material. Therefore, liquid and gases can be categorized under fluid. Therefore, liquid and gases can be categorized under fluid. Have the idea that topic hydrostatic. The right under hydrostatic part. Here, we will study about liquids only. Liquids only. Therefore, it is called as hydrostatic. It is called as hydrostatic. The following three lessons will be discussed under this part. The following three lessons will be discussed under this part. What do they think? May lessons to the first one is density. Density of a liquid. Then pressure. Third one, upthrust. Those are the three subsections we are going to study in hydrostatic lesson. Hydrostatic. Correct. But as we discussed earlier, liquids. Sorry, actually, fluids. Fluids means both liquid and gases. Both liquid and gases. Therefore, we have to discuss about some characteristic of liquid and gases. Liquid and gases. Therefore, first of all, we can list out some special characteristic of liquid and gases today. Liquid gases. There are topic characteristic features, some characteristic features of liquids and gases. Some characteristic features of liquids and gases. Some characteristic features of liquids and gases. හරි. මේවා නිකන් අර හතේ යටේ පන්ති ඔයගොල්ලෝ ඉගෙන ගත්ත දේවල් අය පරක්කම මතක් කරගන්න. හරි. නමට හැමෝගෙම answers ඕනේ. I need answers from everyone. So tell me some characteristic of liquids. Some characteristic of liquids. Tell me some characteristic of liquids. ටක් ගාලා. එක්කෙනා එක ගානේ කිව්වත් කියන්න පුළුවන්.
Have no shape.
Yes. It has no shape. Liquid has no shape. Very good. Liquid has no shape. Then gases. What about gases? Actually, normally liquids take the shape of the container. Shape of the container. Neither. If you pour some liquid into a bottle, it takes the shape of the bottle. If you take another, if you pour the liquid into another type of vessel, it will take the shape of that vessel. Therefore, liquid has no shape. It has no shape. It takes the shape of the container. It takes the shape of the container. So what about gases? What about gases? Actually, both gases and liquid have no shapes with it. It has no shape. It has no shape. It can take the shape of the container. Shape of the container. Okay. Has no shape. It has no shape. It takes the shape of the container. This sentence or this characteristic is common for both gases and liquid. It is common for both gases and liquid. Then what else? What else? මොකක්ද? ලෙසද? දීනත්? කියන්නකෝ. ශෂෙන්ද්‍ර? Another characteristic. Some different characteristics. What are the different characteristics between liquid and gases? Yes, liquid has considerable higher density than gases. Yes. Yes, very good for that. Actually, the most actually there are some differences with it, but අපිට ගන්න පුළුවන් හොඳම difference එක. What is the most what is it? There are some differences with it. There are some differences, but you can see liquid has a defined volume with it. But gases, it doesn't have a defined volume. Why? Gases can take the volume of the container. If the volume of the container is increased, gas can increase its volume. Therefore, gases can take the volume of the container, but liquid has some definite volume. It has a volume of the volume of a liquid. Volume of a liquid is a constant. Is a constant means it has a defined value. And දැන් මේ ඔයා හිතන්නකෝ මේ වතුර මොකක් හරි වතුර මිලිලීටර් 100ක් විතර අරගෙන ලීටරේ බෝතලයකට දැම්ම කියලා එයාගේ වොලියුම් එක වැඩි වෙන්නේ නැහැ නේද? Therefore liquid has some different volume, but gases has no exact volume, but it can take the volume of the container. Volume of the container. Yes, Puti, very good. Listen. Yes. Yeah, in liquid, there are some particle clusters. Particle clusters. That means particles are arranged as some clusters. Therefore, although they can have some translational motion, but that motion is limited to it. But gas materials, if you consider about gas materials, actually they can do some random motions. They can do some random motion. Therefore, gas materials have some random motions, but liquid materials, or actually, although it can move, there's a limitation. That's limitation. The other thing is some liquids, the density of some liquid or volume of some liquid, sorry, density, not density, the volume of some liquids is a constant. But actually, we cannot change the volume of some liquid by applying forces. Suppose now there is a liquid here. Now this liquid has a volume limit. Actually, this volume cannot be changed by some applied force on it. Therefore, some liquid has some exact volume. Exact volume means volume cannot be changed by applied force. Those kind of liquids are called incompressible liquid. Incompressible liquid. We cannot compress that thing. We cannot compress. We cannot change the volume by compressing. That's why we call it as incompressible liquids. But all the gases are compressible. All the gases are compressible. That means we can compress gases. We can change the volume of gases by applying forces. Okay. අපි force එක apply කරලා gas එකේ volume එක change කරන්න පුළුවන්. ඒ වුණාට සමහර liquid වල ගොඩක් liquid වල අපිට volume එක change කරන්න බෑ force එක apply කරලා. සමහර වෙලාවට පුළුවන් නමුත් සමහර වෙලාවට. Okay. We can note down the thing. Second thing. මේක දාගන්න. Liquid has an exact volume. Okay. අපි සාමාන්‍යයෙන් ගෑසස් වල ක්වෙස්චන්ස් හදද්දී පුතේ ගෑස් එකේ වොලියුම් එක කියලා ගන්නේ ඒ ගෑස් එක දාලා තියෙන කන්ටේනර් එකේ වොලියුම් එක. And therefore volume of a gas, the volume of a gas is defined as the volume of the container. Volume of the container. Then next one. තමයි ලියාගෙන මම පොඩ්ඩක් තම්බයක් දාන්න. Okay, then write this one. Some liquids, some liquids cannot be compressed, cannot be compressed, cannot be compressed cannot be compressed by applying an external force. By applying an external forces. An external force. Then in the liquid gases column, the gases column, but all the gases can be compressed. All the gases can be compressed by external forces. Then the next point. ඊළඟ point එක අරක දාගන්න විතර මේ liquid spec column එක දාගන්න මේ in the liquid column please write this one මේ within the brackets those kind of liquids are called incompressible liquids. Those kind of liquids are called incompressible liquids. Then like the fourth one. Particles of a liquid particles of a liquid arrange particles of a liquid arrange as clusters arrange as clusters ඊළඟට එහා පැත්ත දාගන්න particles of a gas have random motions have random motions therefore they cannot have a stationary state therefore they cannot have a stationary state with it. That means, although the gas is in a stationary condition, the particle inside that gas have random motion to it. Therefore, those particles are not in stationary state. And gas එක flow වෙන්නේ නැති වුණාට gas එක ඇතුළේ තියෙන particles එහෙම move. Okay. Then I have a topic, density of a liquid. Density of a liquid. Now, topic here, Pute. This is a topic. This is the main topic. So as we discussed earlier, there are only three lessons in fluid study: density, pressure, and upthrust. Density, pressure, and upthrust. So this is the first topic, density. So how to define density? We know how to define density. Density means mass divided by volume. Okay. So this is the definition of density, mass divided by volume. Okay. That is applicable for any kind of material, not only a solid material, but also a fluid. Okay. Density of fluid. So mass is measured by kilogram. This one is measured by meter cube. Therefore, unit of density, normally density is represented by rho. Therefore, unit of rho is kilogram per cubic meter. As well as we can use gram per cubic centimeter. Those are the two mainly used units. And the dimension of density is equal m L minus 3. M L minus 3. Medical dynamic density. Medical dynamic. You know how to convert kilogram cubic meter to gram cubic centimeter. So how to convert kilogram cubic meter to gram cubic centimeter? What is the relationship between them? Tell again. What is the relationship between kg m minus 3 and gram cm minus 3? ഏതൊക്കെ relationship එකකට? එහෙම අප්පා. ඕ කතා කරන්න ඕනේ කතා කරන්න. මොකද්ද යකුනේ relationship එක? නේද? හ්ම්. මේක මතක තියාගන්න මේ මොකද්ද මේ water වල තියෙන density. So what is the density of water? 1000 kilogram cubic meter per cubic meter. But if you write it is in gram per cubic centimeter, it is equal to 1. It is equal to 1. Therefore, you can remember it using yes. 1000 kilogram cubic meter per cubic meter should be equal to 1 gram cubic centimeter. Remember it using the density of water. Density of water. 1000 kilogram per cubic meter is equal to 1 gram per cubic centimeter. Therefore, if you are given kilogram per cubic meter, then you can divide it by 1000 and get gram per cubic centimeter. So this is the relationship between kilogram per cubic meter and gram per cubic centimeter. Yes. Milan. Okay. Elaborate question. Now, if we consider about a material, okay, if we consider about a certain material, what can you say about the density of that material? Is it a constant or is it a variable? If we consider about a certain material, does the density a constant or not? Or it is a variable? If it is a variable. Density කියන්නේ constant එකකට මොකක් හරි material එක නැත්නම් variable එක. වෙනස් වෙන්න පුළුවන්. Can it be changed? Okay. So if you consider about a certain material, the mass should be a constant. Is that clear? If you consider about certain material, if there is a actually if you consider about certain material, the mass should be a constant because mass depends on number of particles. So if we consider about a certain material, the number of particles are constant. If it is not replaced, if they are not replaced, then those number of particles are constant. Therefore, mass is a constant. Therefore, if it is a variable, how could it happen? No, material to material vary. I mean, Pute, if you consider certain material means no, material is a constant. Material is a constant. So if you consider about some iron piece, now this material is a constant. Okay. If we consider a certain material, the material is a constant. So I'm asking if it is a constant, if the material is a constant, then the density can be changed or can be varied or not. Yes, we know if you consider a certain material today, if we consider a certain material, that means if we consider about some iron piece or some amount of water, some amount of any liquid, some amount of any uh, gas, or if you consider about any solid material, that material is a constant. That material is a constant. Therefore, number of particles inside that material is a constant. So, definitely, the mass of a certain material should be a constant. But the thing is, the volume. The volume can be changed according to the with temperature. With temperature. Because you know when temperature increases, volume of any material can increase. Therefore, according to temperature, volume varies. That means density varies. Therefore, density can depend on temperature. Density can depend on temperature. If you consider about certain material, if the mass is a constant, if the mass is a constant, then if the mass is a constant, then when temperature increases, you know, volume increases. When temperature increases, volume increases. That means density should be decreased. Density should be decreased. But this depends on some factors. සමහර තැන්වල density එහෙම වෙනස් වෙන්න දැන් තියෙනවා විශේෂයෙන් water වල හැම. අපි දැන් කතා කරනවා heat present එකේදී. හරි. මේ එහෙම මෙහෙම වෙන්න ඕන නට මෙහෙම නොවෙන තැන් තියෙනවා. Okay. Then I this one. The density of a certain material can be changed with the temperature. Can be changed with the temperature. When temperature changes, when temperature changes, the volume of that material, the volume of that material can be changed. Can be changed. I will repeat it again. I will repeat it again. The density of a certain material, the density of a certain material can be changed according to temperature. ඒකම වෙන්න පුළුවන් පොඩ වෙනස් ඇති. The density of a certain material can be changed according to the temperature. When temperature increases, volume of that material, sorry, Raduna, when temperature changes, when temperature changes, when temperature changes, the volume of that material can be changed. The volume of that material can be changed. Yeah. Then we have discussed about the density. Density ගැන අපි කතා කරා. Okay. ඊළඟට අපි question එන්නේ පුතේ density එක්ක වඩා ඊළඟට කතා කරන කොටසත් එක්ක. That is relative density. Relative density. The right topic. Relative density of a material. Relative density, normally we call it as relative density RD or simple D. Normally simple D is used for density also, but in as a regular practice, we use simple D for relative density. But there is no any mistake to use simple D as density. Density will be what කිසිම වැරද්දක් නැහැ. Those are not standard symbols. Maybe standard symbol anyway, but those are some regular symbols. What is relative density? Relative density is defined as the density of a material relative to the density of water. Density of a material relative to the density of water. Therefore, relative density is defined as the density of a material divided by density of water. Density of material divided by density of water. Okay. So if you consider about this one as raw material and raw W. Density of water, if you consider density of water as raw W and density of material as raw M, then relative density is defined as raw M divided by raw W. So you know, in the numerator there is a density, in the denominator there is also a density. Therefore, this is a ratio between two densities. So definitely, if we use units, unit of density will be cancelled out. Unit of density, therefore there will not be any unit for relative density. Okay, as there's no unit, there's no dimension. Therefore, relative density has no unit own division. As well. Unit of division. Is that clear? If it is clear, please raise the hand. Tena Kusami. Pahadili to sa tena. Right. अब examples वगैरह का तो मैंने निकाला examples work है ना. Well, normally density of oil can be considered as 800 kilogram per cubic meter. This is density of oil. Therefore, relative density, or I thought D oil. Relative density of oil means density of oil divided by density of water. Density of divided by density of water. When you are dividing, you have to take both densities in same unit. Both densities same unit. Therefore, this is equal density of oil divided by density of water. Density of oil is 800. This is 1000. You have to use two densities in same unit. Therefore, density D oil, relative density of oil is 0.8. 0.8. Then, density of mercury. Density of mercury, we know that thing is 13,600 kilogram per cubic meter. Therefore, simple D mercury is equal, you have to divide this one by 1000. You have to divide this one by 1000. That means 13,600 should be divided by 1000. That means 13.6. 13.6. This is relative density of mercury. Okay. Right. If you get that one, please raise the hand. Okay. Note down this thing. Maybe once you finish, please let me know. Hello, Bhuti. Shall I erase it? Yeah. Marlon Bhuti, what example? Yeah, we can look into some examples, real-time examples. Yeah. Okay, we can look into some density of materials in kilogram cubic meter per cubic meter and gram per cubic centimeter, and we can determine relative density. So if we can answer first one is water. You know, this one is 1000. You can take gram per cubic centimeter by dividing this by 1000. That means 1. So what is the relative density of water? Relative density of water here. Tackle again. What are the relative density? Here. What is the relative density of water? What are the relative density here? Go ahead. Yes, very good. Yes. The relative density of water means that is 1, no? Yes. Yes, that is 1. Then oil. Sometimes these values may vary with a little bit, but normally oil has a density of 800. Therefore, 800 per kilogram per cubic meter. So, gram, if you convert it into gram per cubic centimeter, it will be 0.8. 0.8. You have divided by tens of thousand. Now tell me what is the relative density of oil? What is the relative density of oil? What is the relative density of oil? Oil relative density? Like that again. Oil relative density. Yes, 0.8, 0.8, 0.8. Yes, put 0.8. Yes, 0.8. Now, can you guess some relationship between density and relative density? Can you guess any relationship relationship එක පේන්නේ නැද්ද ඔයගොල්ලෝ? තව එකක් කරන්න ලියන්න. ice cube paradise. ඒක කීයද? Normally 9,000. Therefore, if you consider about the density in gram per cubic centimeter, you have to divide this by 1000, 0.9. What is the relative density of ice? What is the relative density of ice? Yes, very good. 0.9, 0.9. Now tell me, is there a relationship between density and relative density? Is there a relationship between density and relative density? ये दिन अगर संबंध थी ना हम्म संबंध थी ना क्या yes very good for this Shashindra yeah yes very good relative density of a material relative density of a material relative density of a material is equal to the density of that material in gram per cubic centimeter. Gram per cubic centimeter. Just the value, only. Just the value. Unit එකත් එක්ක නෙමෙයි. හරිද? මෙයා ඕනෑම material එක density එක gram per cubic centimeter වලින් ලියුවොත් ඒකේ ආගේ relative density එක. හරි. then what? Alcohol. Normally it is about 750, 800 probably. 750 again. Therefore, this one should be 0.75. That means this one also 0.75. Then iron. Iron 7,800 again. So if you divide it by this, if you divide this one by 1,000, then 7.8, 7.8, 7.8. So what is the relative density? That also equal to 7.8 Putin. 7.8. Then 6 one. Yeah. Air has density 1.3. 1.0 again. Let's make 1,000 when you divide curve. 0.0013. Okay. Therefore, this one is also 0.001. Yeah. Then density of mercury density of mercury is equal 13,600. That means 13.6. That also equal to relative density 13.6. Therefore, we can easily say relative density. Make relative density of a material relative density of a material equal density in gram per cubic centimeter. Density in gram per cubic centimeter. Okay. So after writing this one, you can write this. Okay. Tackle my. Okay with it. The other thing is, uh, actually, relative density can be defined for any kind of material. No, these are liquids. Actually, this is a solid. This is a solid. These two are liquid. This is solid. This is a liquid. This is a solid. This is a gas. Therefore, therefore, relative densities can be defined not only for liquids but also for any state of matter. Okay, relative density can be defined for every state of matter. Every state of matter. Relative density can be defined for every state of matter. With it brackets, solid, liquid, and gas. Harabuti. So that is the definition of relative density. Normally, if we are given relative density questions, most of the cases it will be based on mixtures. So we have to identify, or we have to study how to determine the densities of mixtures. And uh, so now we are going to discuss about mixtures. So what are the mixtures, Putu? So mixtures can be anything. So in this case, Putu, we are not considering about gases. We are not considering about gases. We are considering about liquid solid, or solid mixtures only. Therefore, mixtures means those are some kind of addition of different material. Therefore, mixtures can be liquid mixtures. There may be liquid mixtures, then liquid plus solid mixtures, then solid mixtures. And කොහොමද අපි මික්සර් එකක් හදන්නේ? නිකන් හිතන්න අපි තේ හදනකොට බලන්න තේ හදනකොට පෙන්නන්නේ. හරිද? දැන් තේක හදනකොට අපි කහට තියෙනවා. දැන් ඔය ඒක තියෙන්නේ ලික්විඩ් ෆෝම් එකක්. මේ ලික්විඩ් ෆෝම් එකට ඕනනම් ඇස්සලා කිරි දාලා තව ලික්විඩ් ෆෝම් එකක් හදලා මික්සර් එකක් හදන්න පුළුවන්. නේ? ඊට පස්සේ ඕකට සීනි දැම්මොත් එහෙම මොකද වෙන්නේ? අර ලික්විඩ් ෆෝම් එකට අපි දානවා සොලිඩ් එකක්. සොලිඩ් එකක් දාලා තමයි මික්සර් එකක් හදන්නේ. හරිද? ඒවට කියන්නේ තමයි ලික්විඩ් සොලිඩ් මික්ස්චර් එකක්. liquid solid mixer. මොකක්ද ඒක? කොහොමද ඒක කරන්නේ? solid mixer. solid mix කරන්න පුළුවන් පොතේ. ඒකත් කරන්න පොඩ්ඩක් high temperature වලදී කරන්න පුළුවන්. high temperature or high pressure වලදී. හරි? high temperature or high pressure වලදී අපිට solid දෙකක් mix කරන්න පුළුවන්. හරි? Okay. So actually we are not considering about that part. Normally we are considering about two parts: liquid mixtures and liquid solid mixtures. Okay. There are the topic. Density of mixtures. Density of mixtures. Density of mixtures. In this case, we consider about the following types of mixtures. In this case, we consider about the following types of mixtures. First one, liquid. Second one, liquid plus solid. Third one, solid plus solid. This is a rare case, Pute. This is a rare case, but those two are some common cases. Look at this one, Pute. Suppose now there is a liquid here. This is liquid A. This is liquid A. This has a mass of Ma and volume of P. And There's another liquid, VB. There's another liquid, B putty. It has a volume of VB and mass of Vm. So if you mix them together, then what will happen? Then what will definitely මොකද වෙන්නේ? පතරවල තව මොකක් හරි බිමක් දැම්මොත් මොකද වෙන්නේ? Definitely the volume will be changed. The volume can be raised and the mass can be increased. Not only volume but also mass can be increased with it. And therefore, when we form a mixture, what will happen? What will happen? The mass as well as the volume can be changed. Mass will as the volume can be changed. The mass. My mass of the mixture ගන්නවා පුතේ simple and mix. ඊළඟ volume එක පුතේ Therefore, we have to determine the density of this mixture. So, density of a mixture, actually, according to definition, density is equal to mass over volume. Mass over volume. Therefore, density of a mixture should be equal. It should be equal. Therefore, density of mixture should be equal mass of the mixture divided by volume of the mixture. That's simple. Mass of mixture divided by volume of mixture. And so in this case, in this kind of questions, we are going to assume the volume of mixture is not changed. That means these volume are not going to change. Actually, most of the cases volume can be changed because there are some spaces in this liquid and there are some spaces in this liquid too. Therefore, when you mix them together, those spaces can be filled with the other material. Sometimes some stronger bonds can be generated. Due to that reason, sometimes the volume can be decreased. But in this case, we are not considering that one because that cannot be calculated. No, the volume change cannot be calculated. It is related to chemistry of that materials. So, in order to convenient calculations, we assume those two volumes are not changed during the mixing process. That means our assumption is the volume of mix should be equal to the sum of these volumes. That means if you add 25 milliliter of this volume and 30 milliliter of this volume, then the volume of mix should be equal to 55. That is our assumption because the actual scenario is volume can be changed. But the thing is, it cannot be measurable. It is not measurable. We don't know the thing. And therefore, we cannot do a calculation. So in such cases, we will make this assumption. If you got my explanation, please raise the hand. I need response from everyone. Yeah. Okay, now you can write down this thing. Here, the volume of mix should be equal volume of A plus volume of B. Volume of A plus volume of B. Mass එකත් එක්ක mass එකත් වෙනසක් වෙන දෙයක් නෑ. mass එකත් වෙනසක් වෙන දෙයක් නෑ නා. mass එකත් ඒ කියන්නේ දෙක එකතු වෙන්නේ මේ mass එක mass එක. හරි මොනවද? mass of mix. Therefore, volume of mix MA plus MB VA plus B. This is our final equation. Volume of a mix, sorry, density of mix is equal to addition of two masses divided by addition of two volumes. Addition of two masses divided by addition of two volumes. හරි. මෙච්චර ලේසිලා මොන කිව්ව මම මේක හදන්න තියෙන කියලා හිතේ නේද? පුතේ, actually this is the equation. You have to add two masses and two volumes, then you can determine the density of mix, putte. So it is very easy. But the thing is, sometimes we are not given either mass or volume of some liquid. Okay, we are not given. So in such cases, we have to develop a methodology to determine the mixed, sorry, raw mix. So that will be the question. That will be the question. Sometimes we are not given that thing, so we have to determine that thing using densities. Using densities. Actually, there are three quantities, three physical quantities. One is mass, other one is density, other one is volume. Mass, density, volume. There's a relationship between them. What is the relationship? Density is equal to mass over volume. Therefore, if you are not given mass, then you can determine mass by multiplying density and volume. If you are not given volume, it can be determined using mass and density. Mass and density. It is a very easy thing. And therefore, if there's a question based on this topic today, then most of the cases, mass or volume may not be given. So in such cases, we have to determine that thing using the relationship between those three physical quantities. Density is equal mass over volume. That is the relationship. That is the relationship. Using that relationship, we can find either mass or volume. Yeah, if we are not given either mass or volume of a certain material, if we are not given either mass or volume of a certain material, we should determine that during the calculation. We should determine that during the calculation. Okay. They write one when mass is not given. When mass is not given. Okay. Suppose there is a material today. This is material 1 today. It has a density V1, mass M1, mass M1. Volume V1. Math එක එකතු කරනවා the second material. The second material density is ρ2, mass is M2, V2. And mass is V2. Yeah. Then suppose here we are not given these masses. Suppose M1 and M2 are not given. M1 and M2 are not given. And so in such cases, I have to do this. AC. Now, this is our mixture today. So mixture should have mass M1 plus M2 and volume V1 plus V2. So as mass is not given, I can determine mass using that equation. Applying rho equal M over V, mass is equal M into V. M into V. Therefore, M1 is equal rho 1 V1. M2 should be equal rho 2 V2. Therefore, density of mix is equal M1 plus M2. M1 plus M2 divided by V1 plus V2. V1 plus V2. So M1 plus M2 means M1 means rho 1 V1 plus rho 2 V2 divided by V1 plus V2. Correct. Very simple. Yeah. But here there is some interesting part to be remembered. Remember, look at this one. If V1 equal V2 equal V, that means if equal volumes of two materials are mixed, normally we considered about liquid mix but when equal volumes of two materials are mixed, V1 and V2 equal V. When equal volumes of two materials are mixed, then put V1 equal, V2 equal, V. V cannot be convertible. Therefore, in such cases, rho mix is equal. Here you can replace V1 and V2 by V putty. Rho 1V plus rho 2V divided by V plus V means 2V. Therefore, V will be cancelled out. This is the interesting part. If equal volumes of two materials are mixed, rho mix is equal rho 1 plus rho 2, rho 1 plus rho 2 divided by 2V. That means if equal volumes are mixed, and if there is no volume change, if equal volumes are mixed and if there is no volume change, the density of mixture should be equal to the average density. Is that clear? Is that clear? Tena question? Finish. Okay. Shall I rest? Okay. சரியா? Okay. When volume is not given. When volume is not given. When volume is not given. So now you have to find volume puthe. We have to subject volume here. So volume is equal M over rho. M over. Therefore, M mass is given puthe. Therefore, M1 plus M2. Instead of V1, I can write M1 over O1. Here M2 over O2. So this is the density of mix. This is density of mix. Uh, uh, So it is very clear in density of mix there are only M1 and M2 as well as O1 and O2. Uh, suppose if we mix equal masses, Marlon Pathirage here, when equal masses are mixed, what will happen? M1, M2 can be written as M to the. When equal masses are mixed, M1, M2 can be written as M. Therefore, rho mix is equal M1, M2 can be written as M to the. Therefore, M1 plus M is M plus M is 2M. 2M divided by M over rho 1 plus M over M2 and 2 M will be cancelled out. Then if you consider the common denominator, then here rho 2, rho 1 here, then rho 1, rho 2 should be in the numerator. Therefore, rho mix should be equal 2 times rho 1, rho 2, 2 times rho 1, rho 2 divided by rho 1 plus rho 2. So this is for equal masses. When equal masses are mixed and the volume of final mixer is equal to the sum of two volumes, then the density of mixtures is equal to 2 times rho 1 rho 2 divided by rho 1 plus rho 2. And actually, if you can remember those two equations, then it will be much preferable for MCQ questions. Take that. Okay, have finished. Okay, thank you. Okay, now we can write a special note. That is special note. Okay? Note number one. In this kind of questions, in this kind of question, we assume there is no volume change during the mixing. In this kind of question, we assume there's no volume change during the mixing. Second one, if there is no volume change during mixing, if there's no volume change during mixing, when equal volumes are mixed, rho mix is equal rho1 plus rho2 over 2. When equal masses are mixed, rho mix is equal to times rho1 rho2 divided by rho1 plus rho2. Third one, third one. As we can divide the both sides of the equation, as we can divide the both side of the equation by rho w, as we can divide the both side of the equation by rho w. Again, okay. As we can divide the both side of the equation by rho w, मेरी क्रिया करना third one. As we can divide the both side of the equation by rho w. The relationship between relative densities the relationships between relative densities are also same. Okay, I will repeat the first one. I will repeat the first one again. In this kind of questions, we assume there is no volume change during mixing. That is statement number one, note number one. And in this kind of questions, we assume there's no volume change during mixing. The second one, as there is no volume change during mixing, as there is no volume change during mixing, here are equations දෙක දාගන්න. When two, sorry, when equal volumes are mixed, when equal volumes are mixed, rho mix is equal rho 1 plus rho 2 divided by 2. When equal masses are mixed, rho mix is equal 2 times rho 1 rho 2 divided by rho 1 plus rho 2. As there's no volume change, as there's no volume change, then I'm gonna when equal volumes are mixed, rho mix is equal rho 1 plus rho 2 divided by 2. When equal masses are mixed, rho mix is equal 2 times rho 1 rho 2 divided by rho 1 plus rho 2. හරිද? If someone may miss the sentence, please raise the hand. එක මෙතේ මගෙන් නතුස. Okay. Have you written the first one? First note is okay, no? Note number one. If note number one is okay, please raise the hand. If you write the note number one, please raise the hand. Note number one එක ලියවන්න නතුස. නැන්ද? I need response from everyone. මේක හැමෝගෙම මට respond ඕනි. නැත්නම් මම ආයෙසරක් කියවන්න වෙනවා ඒක. හරිද? Note number one ලියුවේ නැත්තම් නතුස. Note number one ලියුවේ නැත්නම් අපා කට්ටිය මම hands down කරගන්න. Note number one ලියුවේ නැත්තම් නතුස. දහම් දෙකද ලියුවේ? ලියුවේ නැද්ද? ආයෙ පාරක් වන්න මම කියනවා. Note number one. In this kind of questions, we assume there's no volume change. In this kind of question, we assume there's no volume change. ටග්ගා ලියන්න පාරක් වෙනවා. In this kind of questions, we assume there is no volume change. The second one. Second one, you have to second one, leave නැති කට්ටිය තුස්ස. Thank you. Third one තමයි අපිට clearly හිතේ. Third one මොකක්ද දින්නේ මම මතකත් නැහැ. අතන රිප්ලේස් කරන්නේ නේ. Okay බලමු පුතේ. You know, when the mass is not given, you know, rho mix. When mass is not given, rho mix is equal. What the M1 means rho 1 V1 plus rho 2 V2 divided by V1 plus V2. When mass is not given, mass again mass V1 plus V2. So if we divide both sides by rho W, if we divide both sides by rho W, if we divide both sides by rho W, rho mix divided by rho W is equal. You can divide both. मैं कहता हूँ rho W के बेलन पुट. Rho 1 divided by rho W V1 plus rho 2 divided by rho W divided by V1 plus V2. Rho 1, rho mix divided by rho W means that is relative density. This one is relative density of 1. This one is relative density of 2. Therefore, we can replace all the things by relative density. Therefore, relative density of mix should be equal relative density 1 V1 or relative density 2 V2 divided by V1 plus V2. Therefore, the same equation can be replaced by relative density. The same equation can be replaced by relative density. That is obvious. That is obvious. Why? Relative density is equal to the density in gram centimeter cube. Therefore, if we replace the density in gram cubic centimeter, then we can convert it into relative density. Therefore, this equation is valid for densities as well as to the relative densities. Therefore, when two equal volumes are mixed, relative density of mix should be equal d1 plus d2 divided by d1 plus d2 divided by d. Pega tapi dia menggunakan itu. Tadi tanya pula. When volume is not given, that means mass is given. Therefore, I can write mass here. Then divided by volume. Volume is not given. Volume can be written as mass over density. Mass over density. Then I can divide both sides by rho W. Is equal M1 plus M2. M1 O1 plus M2 O2 divided by, if you divide this side by rho W, you have to divide this entire equation by rho W, right? If you divide this side by rho W, you have to divide this side by rho W. You can divide this side by rho W. Is that clear? If you got that one, please trace that. If you got that one, please say there. Ah. Then rho W, so rho mix divided by rho W. Rho mix divided by rho W means density, relative density of mix. Put the relative density of mix. Relative density of mix is equal M1 plus M2 put the money divided by, I can divide this by separately, but I can divide this by separately. That means M1 divided by rho 1 over rho W plus M2 divided by rho 2 over rho W. Is that clear? If you got this one, please say that. Or make a divide. If you got my calculation, please raise the hand. There on this one. Thank you. So rho 1 divided by rho W means relative density of liquid 1. Rho 2 divided by rho W means relative density of liquid 2. Liquid 2. Therefore, relative density of mix is equal M1 plus M2 divided by M1 relative density of 1, M2 relative density of 2. M2 relative density of 2. Therefore, the same equation can be replaced by relative density. The relative density. As I told you earlier, it is obvious. Why? Density. So if we apply density values in gram per cubic centimeter, it will be relative density. It will be relative density. Therefore, there is no difference between these two equations. Therefore, definitely you can substitute or you can replace density values by relative density. Relative density. Is that clear? If it is clear, please raise the hand. There are to Thank you. Okay, finally, after writing this one, you can write this one. Again, pass it again. Again, pass it. Again, pass it. Therefore, when equal masses sum is relative density of mix. Relative density of mix should be equal relative density of 1 and 2, 2 times relative density of 1 and 2 divided by d1 plus d2. d1 plus d2. Okay. You can note down this thing, Pute. From this point, Pute, density part is over. Density කියන එක අහලා අපි ඉවරයි. තව දෙකයි අපිට කරන්න තියෙන්නේ. Okay. Once you complete writing, please take the tube number one. Please take the tube number one. Relative density tube. Relative density tube number one. And do the question number one. Do the question number one. Try to do the question number one. Okay, first chart. A volume of 400 cubic centimeter of a liquid A of relative density of 0.8 is mixed with a volume of 600 cubic centimeter of a liquid of B. Relative density so liquid B of relative density 0.6. If no change of volume take place during the mixing, find the density and the relative density of the mixture. Now you are given 400 milliliter of liquid A. Sorry, 400 cubic centimeter of liquid A. The relative density is 0.6. Sorry, 0.8. 0.8 plus 600 milliliters. 600 cubic centimeter of liquid B, 0.6 millimeter. That means you are not given the mass. You are not given the mass. So once you add them, the total mass should be equal M1 plus M2. M1 means MA plus MB. MA plus MB. Total mass is equal to mass of A plus mass of B. Mass of B. Mass of A plus mass of B. And total volume is equal VA plus VB. VA plus VB, that means 1000. Therefore, density of relative density of mix equal and the density definition. Density of mix equal mass of total mass of the mix divided by total volume. So mass of the mix is not given to there, therefore, so mass of each material is not given, therefore you have to find that using rho equal M over V equation. Therefore, mass is equal rho into V, that means rho A into VA plus rho B into VB divided by VA plus VB. Our standard equations we make is MCQ. Therefore, if you divide both sides by rho W, then dividing rho W. Dividing both sides by rho W. Then the relative density of mix equal relative density of A plus relative density of B. Relative density of B divided by VA plus VB. Then relative density of mix is equal, relative density is 0.8. 0.8 into 400 plus 0.6 into 600 divided by addition of volume is 1000. Therefore, this one to this one will be cancelled out. 10 will remain. 10 will remain 0.32, 0.32 plus 0.36. 0.36. That means 0.68. Relative density of mix is equal 0.68 to 0.68. Therefore, density of mix should be equal. We have to multiply this by 1000. That means 680 kilogram per cubic meter. 680 kilogram per cubic meter. Is that clear? Maybe Theonon Tucson, if you got that one, please place there. Theonon Tucson. මේ ඉක්වේෂන්ස් එකක්වත් ස්ටෑන්ඩඩ් ඉක්වේෂන්ස් නෙමෙයි. ඒක නිසා එසේ ඉක්වේෂන් එකක් හදනකොට මේක අනිවාර්යයෙන් මේ විදිහට හදන්න වෙන්නේ. හැබැයි MCQ ඉක්වේෂන් එකක් හදනකොට ඉතින් ආය අහන්න දෙයක් නැහැ නිකම්ම හදන්න පුළුවන්. හරි. හඳ. Then do the question number 4, 5, 6. 4, 5, 6. Do the question number 4, 5, 6. In tooth one. Do the question number 4, 5, 6. In tooth one. 4, 5, 6. Have finished? कंप्लीट कर बैठे तो सर हाँ वेरी गुड हाँ ओके बाय ओके fourth one the mass of an empty relative density bottle is 21.8 its mass is 41.8 when filled completely with water and 40.6 when filled completely with a liquid. Find the relative density of liquid. Then, may want not take it, no, may not take one instead of the Dani. Put it, look at this one. If we consider a mass of some material, suppose I am considering V volume of simple A material, V volume of simple A material, and mass of that one is M. And then I'm considering the mass of water sample that had the same volume. Mass of the water sample that had the same volume. Water and volume make the same volume. Mass is same W. So you know, if we write the relative density equation, relative density of material is equal density of A divided by density of water. Density means mass divided by volume. Mass divided by volume. Therefore, density of this material is equal mass divided by volume. And density of water can be written as mass divided by volume. And W divided by same volume. Volume are equal. Therefore, the relative density of a material can be written with a V2V will be cancelled out. Mass of A divided by mass of W. That means mass of a material divided by mass of a same volume of water. Mass of a material divided by mass of a same volume, the same volume of water. And we can measure the same volume. Volume is equal. And therefore, mass of a material, mass of a certain volume of a material divided by mass of the same volume of water. Same volume of water. Therefore, relative density can be written as a division between two masses with equal volume. Therefore, relative density is equal to the ratio between two masses with equal volumes. Two masses with equal volume. അനിവാര്യം കൊടുത്തേ two masses with equal volume. Then take your note, and write this one as a special note. अब ये relative density है ना बुते equations देखा कथा करा. What are those two equations? Ratio between two densities. Two densities mean one density should be the density of material, other one should be the density of water. Relative density is equal to density of two ratio between two densities, and the second equation is ratio between two masses with equal volumes. Two masses with equal volumes. Hello. Okay. Now look at the question number 4. Now look at the question number 4. In question number 4, it is given the mass of the empty density bottle putted. Mass of an empty density bottle. So density bottle means it is something like this type of bottle. Sorry. So this is used to measure densities. So initially we can measure the weight of or mass of not weight, mass of the empty density bottle, and it is given 21.8. 21.8. Therefore, mass of bottle is equal to 21.8. When you fill that bottle with water, if you fill that bottle, if you fill completely that bottle with water, the mass is 41.8. Mass is 41.8. That mass means mass of the bottle plus water. The mass of the bottle plus water. Bottle plus water is 41.8. That means mass of water. Mass of water means the difference of between them, that means 20. Then if you fill the same bottle, if you fill the same bottle with another liquid, yeah, 40.6. If you fill the same bottle with another liquid, the mass is 40.6. Mass is 40.6. That means mass of bottle plus liquid is equal 40.6. 40.6. Therefore, mass of liquid is equal 40.6 minus 21.8. 21.8 කියලා කියන්නේ විශ්ලේෂණ 18යි 18.8යි. Yes, 18.8. So, hold on. Yes. 18, no? $19.8. 18.8 gram. 18.8. 18.8 gram. 40.6, 41.69, 41. 18.8 gram. 18.8 gram. Yeah. So, this mass is equal to the volume of a water, which is equal to the volume of the density bottle. And this mass is equal to the volume of that liquid, which is equal to the volume of that same density bottle. That means volume of water and volume of liquid are same in this case, because in both cases the density bottle is completely filled by the water and the liquid. That means the volume of water and volume of liquid should be equal. Volume of water and volume of liquid should be equal. Therefore, relative density of liquid should be equal ml divided by mw. ml divided by mw. ml means mass of the liquid. mw means mass of the water of same volume. Mass of water of same volume mass liquid. Therefore, here 18.8 divided by 20. That means 0.94. 0.94. If you got that answer, please raise there. If you got my explanation, if you understood my explanation, please raise there. Then, fifth one. The mass of an empty relative density bottle is 25.5. මම ඒක පොඩ්ඩක් ස්කිප් කරන එක මගේ ක්වෙස්චන් එකක් නිසා. මම ක්වෙස්චන් නම්බර් 6 බලන්න. A volume of 200 centimeter cube of water is mixed with volume of 100 centimeter cube of menthol. Find the mass of each liquid in the mixture. What is the average density of the mixture? Average density of mixture. The density of water and the methanol are respectively. Voilà. Question number 6. A volume of 200 centimeter cube of water is mixed with the volume of 200 millimeter cube water. 200 centimeter cube of water. Density is 1000. Density is 1000 in 1 gram per cubic centimeter. तो करना है मेगा water पुते मेगा methanol 100 cubic centimeter. Density is 0.8 gram per centimeter. Find the mass of each liquid in mixture. Mass of each liquid in mixture. Actually, those mass are not changeable. They will not be changed. Therefore, mass of water should be equal density into volume. Density into volume. Density into volume. Therefore, this one should be 1 into 200. That means 200 gram. 200 gram. M methanol should be equal density into volume would be cubic centimeter to per cubic centimeter will be cancelled out. Therefore, answer is 80 gram. 80 gram. If you got that one, please raise the hand. Then also mass into density. Mass into density. Mass into density. Sorry, mass volume into density. Volume into density. Then, what is the average density of the mixture? What is the average density of the mixture? Then, if you mix them, now mass are determined, mass are determined. Then, the volume. The volume. See the volume. Volume is 300. Therefore, mass of the mixture is equal 200 plus 80 means 280. And the volume of mixture is equal volume of these two 300 cubic centimeter. 300 cubic centimeter. Assume liquid change. Therefore, average density of density of mixture mass over volume. Mass over volume. The mass is 280 gram divided by 300 centimeter. Therefore, this is gram per cubic centimeter. Make it then 14, then 15. Therefore, 4 minutes is equal 0 point. Here the 9 6 5 gram per cubic centimeter. If you got this answer, please say that then on question. Now there are two tubes. Two tubes. I think the first tube there are only 10 questions. There are only 10 questions. Okay. In the second question, tube, there are about 12 questions. No. Okay. So you have to complete all of them. You have to complete all of them and send your answers to me. Send your answers to me. Answers එවන්න note එක මම කිව්වා මතකද අර heat note එක එව්ව එක හොඳයි මොකද heat note එකේ ගොඩක් කට්ටියට mistake තිබ්බ මම එව්වා හරිද ඒ වගේ අනිවාර්යෙන් you have to send your note as well as your answer sheets then I will check that one if there is any mistake I will let you know හරිද දැන් නිකම්ම හිතනවා හීට් නෝට් එක එපෙක ගොඩක් හොඳයි මොකද මේ මොකක් හරි මිස්ටේක් එකක් තිබ්බොත් සමීකරේ ටෝටලි රෝන් එකක් තමයි වාගේ ඔලුවට යන්නේ හරිද ටෝටලිම රෝන් කන්සෙප්ට් එකක් වාගේ ඔලුවට යන්නේ ඒක අනිවාර්යෙන් ගොඩක් හොඳ ඒ මිස්ටේක්ස් ටික හදාගන්න අනිවාර්යෙන් therefore you have to send your note to check as well as we have to send your answer sheets to correct okay so, do you have any questions regarding to this lesson? So, this is all about density. Do you have any questions related to this? Do you have any question? Questions for Hardina? No. Okay, Vijay. Then we can take a break. We can take a break. I will send the other link for heat lesson. Heat lesson will be started at 7:30 p.m. And it is a 3-hour session, 7:30 to 10:30. Okay. Don't miss that time because we are going to complete calorimetry. Calorimetry part complete කරන්න යන questions එක ඒ නිසා miss කරගන්න එපා. හරි. Okay. Then we can take a break now. We can take a break. I will send another link. Okay. Meaning I will send another link. Okay. Don't use this list. Okay. Okay. Everyone. Then you can take a break.